All right, Unit 10. This is going to be the last full unit we get through before our EOC. This is all about quadratic functions. Now, we've been dealing with quadratics. We were factoring them last unit, and everything we're going to learn today, we've already learned, so this is kind of a bit of a review. And we're pulling things we already know together for our quadratic functions. So first we're going to analyze the graphs of quadratics. If you'll notice, first thing you should notice is that instead of a straight line that we have been doing for linear, we have what we call a parabola or a U shape. All right. So the first thing we're going to do is on the back we have some key concepts that we're going to go over, and then some vocabulary we're going to fill in first. All right, so let's put this over. And so, like I said, we have been doing quadratic equations. This is a quadratic equation, ax squared plus bx plus c. We've been doing that. We call them trinomials when we were factoring our trinomials. And this is a quadratic equation. Our x is squared. And just like when we were factoring, we would find a, b, and c. Remember, those are all the integers. And a can be an invisible one, but it cannot be 0. All right? And as we're going to learn in a few minutes, the sign in front of the a is also equally as important. All right, so a, b, and c. We're going to pull those out because we're going to need each of those for different things. All right, the first thing we're going to talk about is, all right, these are 5 key concepts, things you can notice and determine while graphing quadratic equations or figuring out which a graph goes with which quadratic equation, because how you're typically going to see this, and one of the ways we're going to practice it in class, is you're going to be given the quadratic equation, and then you're going to need to match the graph, and you'll be given 4 options. So if you look and know how to find some of these key features of the quadratic function graph, then you'll know and be able to pick out the correct ones. So our first concept is axis of symmetry. Okay. Well, what do we know about symmetry? It means the right side equals the left's mirror image. Okay, they're the same. We know a lot about symmetry in class. So the axis of symmetry, we call it the AOS for short. And it's also the x. Okay, so x equals negative b divided by 2a. So a and b you get directly from your equation itself. Okay, and this will give you the x. And you need the x to find the next thing, which would be the vertex. Okay, your vertex. This will give you the x of the vertex. And then you can solve for y once you have your x. And your vertex will also determine whether you have a minimum or a maximum. Okay, so a minimum is the lowest point, okay? So if you're filling your cup, it's the lowest. And then maximum, if you're dumping your cup out, okay, that's the highest point. But notice these are curves and not points. We are not doing absolute value. Absolute value are your v's. All right, quadratics are u's or parabolas. All right, we're going to define a parabola here in a hot minute. All right, so the vertex, all right, the vertex is either the bottom of the curve or the top of the curve, all right? And then you can, finding your vertex, you have x, you'll solve for y, and they'll give you the exact point of your vertex. Now your y-intercept is kind of cool. Your y-intercept, okay, it's where your parabola crosses the y-axis, And it's when x is 0, what's y? Well, your y is given to you in your equation. It's whatever your c is. Okay, so it's whatever your c is. So there's no math involved. You just have to be able to pick out c from your original equation, and that will be your y-intercept, where this parabola crosses the y-axis. Okay? You may not always have an x-intercept, but we'll be able to find our y-intercept where it crosses the y. All right, now we were talking about symmetry. Okay, and since the right side match the left, sometimes you use symmetry to find additional points on the graph, all right? Because if a point is one space to the left, we can flip it over and move it one space to the right of our axis of symmetry, and we'll do that on the front, okay? So you can see what that looks like. And then lastly, we connect the points in a smooth curve, okay? It's a smooth curve, again, not a point. Points are absolute values, and these are parabolas for quadratics. Okay, so let's get into our definition. There. So a parabola, that's the graph. Okay, it's the U shape, whether upright or upside down, of quadratics. Okay, it's that smooth curve, quadratic functions. Your axis of symmetry, or your AOS. Okay, parabolas are symmetric. Okay, about a central line, and we'll do several of those on the front. Now, our minimums and maximums. A will let you know if you're going to have a minimum or a maximum, okay? So a minimum is the lowest point, and it's when the A of the equation is greater than 0, or it's a positive, all right? So your parabola, you're going to be filling your cup. You'll have a minimum, okay? And then if you have a maximum, that's the highest point. Your A is going to be less than 0, which means your A is going to be negative. So if you have a negative A, you are going to be emptying your cup, okay, and you'll have a maximum. Okay, so anytime you have a negative in front of your A, if you have a negative A, you will have a maximum, or you'll be emptying your cup. All right, so we know some of our key concepts we're going to be looking for. We know our vocabulary. Now let's put it all together, okay? Let's see what we have on the front. So our toolbox, we define quadratics, functions, parabola, axis, vertex, minimum, maximums. We covered those, so we're going to need these words. Okay, so we're going to analyze the graph of quadratic first, okay, and then we're going to do some stuff with it. So the first thing it wants us to identify is your vertex. Okay, remember the vertex. It looks like this is filling the cup, so it will have a minimum. So right here at the very bottom is our vertex. And that vertex address is, what is it? -1, 5. Okay. And this is a minimum. Okay. Our AOS, or axis of symmetry. Okay. Our axis of symmetry. Your axis of symmetry is either going to go through the maximum or the minimum point. So the graph line that goes through the vertex, all right, that is going to be your axis of symmetry, because it's either the highest or the lowest point. And this is where you could fold it in half and your right side would match your left perfectly. So this is your AOS. And your AOS is where x equals -1. Okay, let's talk about our intercepts, all right? Now, this entire graph is above the x-axis, so we don't have any x-intercepts. Could it go through and have an x-intercept? Yeah, it would have 2, okay? This one would have 2 if it was down further, okay? But they don't have to. But we do have a y-intercept, okay? It's where your parabola crosses the y-axis, which is why it's the y-intercept, okay? Y-intercept. And your y-intercept is at 0, 6, okay? Now, could your vertex be the y-intercept if your parabola was up and over? Sure could. Your y-intercept could totally be the vertex if your parabola is graphed a certain way. Totally. Your y-intercept could be your minimum or your maximum of that parabola. It is very possible. All right. So next up, end behavior. Okay. So as the ends of our parabola go towards infinity, what is happening? All right, what is happening? Well, we're sliding down this way. Okay. And then it switches direction at the vertex where we slide back up. Now we've dealt with end behavior before, okay? This is not a new concept. So end behavior. Okay, so what is happening to the y's comparative to what is happening to our x? All right, so first up we're going to do this side. So we are going down. So as x descends, okay, so as x is going down, but these are still pointing up, okay? So as y as descending, as x is descending, sorry, y is increasing. So as your x is decreasing, hence the down, the y is increasing, which is why it's going to infinity, okay? Then what happens once you pass the vertex? Well, then the x increases and the y increases. So the end behaviors, both of your y's are increasing. And what's happening to the x? Well, the x is at first decreasing and then it increases, okay? So the two different directions. But y in this case is always increasing. Okay, we can put that in set notation. Okay, so when are we decreasing? We are decreasing, okay, remember our set notation. We've done set notation before. We're talking about x here first. Okay, so when x is less than -1, when x is less than -1, all right, we are decreasing. And when are we increasing? Well, we are increasing, again, set notation. And again, we're talking about our x when x is greater than -1. So you'll notice that -1 is on here twice. And -1 is our axis of symmetry, okay? So when do things shift and when do we go from decreasing to increasing? It is at that vertex with the line of symmetry. All right. So we talked about when it increases and decreases. Got that? Now, when is the graph positive or negative? All right, and this, what this is talking about is, and we've talked about this before, is it above or below the x-axis? This one happens to be fully above the x-axis, okay? So this is fully above the whole thing. The whole parabola is above the x-axis. So this is always positive. Now, if it was flipped the other way and fully below the x-axis, then it would always be negative. All right, and sometimes you'll have it where it's positive to a certain point and then negative, and then it comes positive again. All right, so it just depends on where the parabola is in comparison to the x-axis, determines if the graph itself is positive or negative. All right, the other thing that it doesn't ask for here, but it will ask for later on, and you will need to know is domain and range. We've done domain and range before, okay? We've done domain and range before. So domain, when we talk about domain, this is your x's, okay? These are your x's. Now, if you'll notice, the x's, it just keeps going, gets slightly wider and wider and wider. And when that happens, we say all real numbers, okay, ARN, or all real numbers, okay? Now, that's your domain, talking about your x's. Now let's look, x's. Now let's look at the y's. Well, the y's itself, you have a constraint with your y, okay? So range is your y's. And what is our constraint? Well, it's right here, okay? That's our minimum. If it was an upside down parabola, it would be the maximum, okay? But that is the constraint. Our y does not go beyond that. So y, in this case, is going to be greater than or equal to 5. Okay? So we're going to hit domain and range again. Okay? We're going to keep coming back to these. These are our skills that we're going to keep coming back to, and these are all the things that you need to be able to pick out when you're doing these. Not necessarily all at the same time, but these are the skills that we will be working on with this unit. Okay, so we're going to do two small graphing quadratics. We're just going to graph a quadratic equation, and then we're going to graph with a table. Now, in reality, if we were asked to do this, like in future math classes, on the job, in college, whatever it is, we'd have a graphing calculator. But for Algebra 1, what they want you to do is be able to match the quadratic equation to a graph that they're going to give you. But in order to do that, you must be able to recognize some of the basic features. And so we're going to do some basic graphing just so we can get some recognition of some of those basic features, okay? So, a couple of things we know just by looking at our equation itself, and remember f of x, that just means a function of x, that's just another way of saying y. All right, so it is going to be asking us for the axis of symmetry. We are also going to find the vertex. We are also going to find the y-intercept. All right, so it asks for those three things. Okay, let's see what we can find. Well, without doing any math, I can find my y-intercept. Okay, y-intercept. And on the back, the y-intercept, well, it's where it crosses the y-axis. So when x is 0, y is what? If you look on the back, when x is 0, y is our c. All right, and the c for this equation is -1. All right, so our y-intercept, 0, -1. All right, so there is our y-intercept at 0, -1. No math required. All right, other thing we can notice is this is a positive. Okay, so we're going to be filling our cup. Okay, so your graph, your parabola, is going to be positive. Okay, so we're going to be filling our cup. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so your graph, your parabola, is going to be positive. Okay, so should look something like that. We're going to fill the cup. Okay. Now the AOS is the next thing, the next easiest for us to find. And it also will give us our x of our vertex. Okay. So we have a formula. It's x equals a negative b divided by 2a. Okay. We've got a, b, c. A is 3. B is negative 6. Don't forget the sign. And C is negative 1. Again, don't forget the sign. We've already used our C. Now let's use A and B. Okay, so that's negative. B is negative 6. And 2 times 3. Well, negative times a negative is a positive, so that's positive 6. And 2 times 3 is 6. 6 divided by 6 is 1. So your x is 1. Okay, so our axis of symmetry is where x equals 1, axis of symmetry. So we're going to draw a dotted line here, okay? Our axis of symmetry. All right. So for our vertex, we have found our x, which is 1. X is 1. Now let's find y. Well, y equals this f of x. So we are going to solve this equation. Okay, we're going to solve this equation. So y equals 3. Well, we already know the value of x. It's 1. So 3 times 1 squared minus 6, x is 1, minus 1. Okay. Well, 1 squared is 1, and 1 times 3 is 3. Negative 6 times 1 is negative 6, and then negative 1. Well, 3 minus 6 is negative 3, minus 1 more is negative 4. So the y of our vertex is negative 4. So 1, negative 4. 1, 2, 3, 4. This is my vertex. It is at point 1, negative 4. All right. Now on the back, that's what we have so far. On the back, right here, we talked about using symmetry to find additional points on the graph. We're about to do that. Okay, we're going to use the symmetry. So we have this axis of symmetry, so what is on the left must match what's on the right. Well, right here, we have our y-intercept, which is 1 to the left. We are going to stay along this graph line and go 1 to the right. So this is the mirror image of the y-intercept. All right, we used our symmetry. So now that we have our mirror image points and we have our vertex, we can now draw our parabola or our curve. Okay, curve up, and there we go. All right, and it just keeps going up into infinity. So we found our AOS, we found our vertex, we found our y-intercept of the given function, we found all of our things done. Okay, now, again, straightforward. When you are trying to identify, okay, the graph that goes with the quadratic, you're going to want to know, okay, where is that y-intercept? That's easy to get, okay, without any math. You can eliminate anything that doesn't have that y-intercept. All right, am I positive or negative? Okay, am I filling my cup or am I emptying my cup? Again, you can process of eliminate without doing any math, all right? Then find your AOS, okay? Find your AOS. And that is the line that the vertex should be on, so your minimum or maximum points. So if your graph doesn't have a minimum or maximum point on that AOS, not your answer. If you still have a couple options, then you can go in and solve for your vertex, okay? So try to do the least amount of math and eliminate as many of them as humanly possible. So let's now do graphing using a table. Okay. So we're going to complete the table for the function. We got a graph, so we have to graph. We have y equals negative 2x squared minus 4x minus 3. We got a quadratic equation. It wants us to graph and state the domain and range. Okay. Very first thing I can do is get my y-intercept. Because again, we've got A is negative 2, we've got B is negative 4, and we've got C is negative 3. And because this is a negative, my parabola, we have an empty cup. We're emptying our cup. And then C, okay, my y-intercept is going to be 0, negative 3. 0, negative 3. 1, 2, 3. Okay. My y-intercept. Oh, look at that. I can fill in this on my table. 0, negative 3. Doesn't even require math. All right. Now, it looks like this one's going to be the mirror image. All right. Negative 2. 1, 2. Negative 3. 1, 2, 3. Yep. This is the mirror image of my y-intercept. All right, so it sure does look like the AOS should be at x equals negative 1. There is 1 point in between my two mirror images, so this is going to be my vertex. All right, so let's solve for our vertex. All right, so this is x. Okay, we have our equation. So let's solve for y. Y equals negative 2. My x is negative 1 squared minus 4. My x is negative 1 minus 3. All right, negative 1 squared, well, that's just 1, and 1 times negative 2 is negative 2. Negative 4 times negative 1 is a positive 4. And then we just bring down that minus 3. Okay, so minus 2 plus 4, that's 2. 2 minus 3 is minus 1. So its y is minus 1. So minus 1, minus 1. This is my vertex of minus 1, minus 1. And you can tell because, well, we would go up and then back down. All right, let's draw a parabola. Okay, we drew our parabola. Okay. We can even, oops. Now, if we were asked our AOS, goes through the graph line that hits through the vertex. So our AOS is x equals negative 1. Okay, so we graphed. Now it wants us to state the domain and the range. All right. Well, again, our x's are our domain, and these are just going to keep going and getting wider and wider. Okay, so the domain is all real numbers. Okay, and your range, or your y's, well, that has a constraint. All right, and we're going down, so we're going to be equal to or less than negative 1. So y is less than or equal to negative 1. Okay? Now, this parabola up here was fully above the x-axis, so this was always positive. Okay, this one here is always positive because the whole parabola is above the x-axis. Well, check this one out. This parabola is fully below the x-axis, and both ends point down. So this one would always be negative, okay? All right. So, and that's it for today. There are 6 problems. All right. So we will continue on tomorrow. Good luck.